Hi folks, I'm Rich Bills and I'd like to take you on an adventure.
Hi folks, and welcome to part 5 of my devlog about building a first-person immersive sim in Godot 4. Last time I explained how the entity and component systems worked and how the components provide discrete chunks of reusable functionality that can be shared between entities, and how the interaction between the entities works using those components. I hope you've watched it all and it made a bit of sense because everything going forward is built on those concepts. In this episode I'll be showing you how I implemented two other core systems, stats and status effects, and how their interactions with one another form key gameplay elements. It's going to be very data focused and uses surprising little code to get everything done, and by the end of it we'll be able to add stats to any entity and have those stats affect the entity's behaviour and the behaviour of other entities that interact with it. Fair warning though, I'll be talking about some unpleasant things like bleeding and hunger and asphyxiation and poisons, albeit in a very abstract way with no gore, so bear that in mind if that sort of thing upsets you. Anyway, onto the code. This is the 1000 foot view of the stats and status event system. Red represents entity nodes, yellow for component nodes, and blue for resources. It's pleasingly symmetrical, purely by chance, not design. Not all of my diagrams will be this neat, but in this case, both the stats side and the event side are essentially doing the same thing. They're both managing a list of resources. Starting at the top, we have the entity that we want to give the stats to. It remains unchanged from before, and we don't need to touch the entity code at all this time. We're going to encapsulate all the stat and status event logic and data into two self-contained components. Let's have a look at the stats component first. The stat component's job is to hold the list of the stats the entity has, and listen out for any changes to any of those stat values. The changes we're specifically waiting for is when the stat hits 0 and when it's healed, or, to put it another way, that's when it's changed from being 0 to a positive number. Any other changes are passed up the chain in case anything else is listening out for any changes. In practice, this hardly ever happens, but is here for completeness. When a stat value has some positive number and becomes 0, it fires its 0 signal, which is caught by the stat component's onStat0 method. We first check to see if there are any repercussions from the stat hitting 0 by checking on the onZero property of the stat that's just gone to 0. It holds a list that may be empty of the effects the entity will gain when the stat hits 0. Not all stats have repercussions from hitting 0. Stamina, for instance, just stops going down any further and you just can't sprint. I could add a non-zero effect to the stamina stat, which gives the entity an exhausted effect that makes their vision blurry, but for now, it just means they can't run. I hope you can start to see how powerful and flexible this simple relationship can be. Let's have a look at the hunger stat. This stat tracks how full the entity is. There's an associated hunger status effect that depletes it over time that we'll look into later. In the case of the hunger stat, its onZero property is a list of just one effect, starving, along with how long it lasts and its severity. The initial duration of 0 indicates the effect is permanent until something else removes it. It never times out. You'll notice there's nothing here to indicate what starving actually does. Only that when the stat goes to 0, the player gets the starving effect, whatever that does. That piece of the puzzle will be handled by the effects component later. So, we run through the list of effects we gain on 0 and add them to the list of effects that the effects component for the entity is tracking. And leave the stats component to deal with that. Great, now we're starving. We'd better eat something. But how do we react to the player eating something? And how do we get rid of the starving effect? What does eating even do? Is anyone else getting hungry? Simply put, eating food raises the hunger stat above 0. This causes the heal signal to be emitted, which we catch here in the stats component's onStatHealed method, which does the opposite of onZero, and it removes the stats onZero effects from the list of effects tracked by the effects component. So hunger goes up and starving effect is removed. So now you have an idea of the stats component's responsibilities. Let's have a look at the list that the stats is tracking. The stats data resource job is to look after the list that holds the stats the entity has, which sounds an awful lot like the job that the stats component is doing. But this is where separations of concerns become important. The stats component isn't concerned about what's in the list, it only cares about when one of the elements hits 0 or is healed, and which one it is so it can deal with the repercussions. If we make the stats component responsible for what's in the list too, that means that anything that we need to have a list of stats and values has to have a stats component, when all they really want is just a place to store a list of stats and values. This separation will become useful later when we look into status effects. You'll see this pattern being reused many times in my code, wrapping arrays and dictionaries in collection classes. This chunk of code is responsible for holding the list of the stats and their current values, and emitting those important 0 and heal signals when any of them change. An entity can only have one instance of a stat at any one time. Having 2 strength stats doesn't make any sense. So that means we can also build a helpful lookup dictionary keyed by the stat so we can quickly get a reference to the stat values without having to iterate through the array every time. This lookup code and any similar code you see from here on in is going to be refactored out once Godot 4.4 lands, as we're going to have type-safe dictionaries. Getting a value from the list can be done in 2 ways, depending on what you intend to do with that value. GetValue returns the current value of a stat as a float and 0 if the stat doesn't exist. It's useful when we want to ask things like, how strong is the entity, for example. It does this by first using the lookup dictionary to find if the stat exists, and if it does, it returns its current value, otherwise it returns 0. GetStats is even simpler. It just returns everything it knows about the stat if it exists, value included. This is useful for the GUI to be able to find out what the icon to display for alongside the stat is. The add method increments the stat's current value or decrements it if the quantity to add is negative. It's not bothered at all if the stat has a maximum, minimum or anything like that. It leaves that all up to the stat value to look after. If the stat doesn't exist, it does nothing. That's a list of stats. Now let's look at the value elements it tracks. Now we're getting to the meat of the stat, its value, the number that we're interested in. To do that, we need a reference to the stat we're storing the number about, and the value itself. Here's where we determine when to send those 0 and heal signals that the stat component is listening out for. We also optionally limit the stat to a maximum value. This stops a player getting infinitely strong as they quaff strength potions. Some stats don't have a maximum value, or they aren't intended to be increased or decreased, like price or weight. If the value changes, we emit a signal so that any GUI elements that are tracking the stat can update themselves. Which leads us to the last link in the chain, the stat itself. It's just a big bag of properties that are used to describe the stat, its name, its icon, etc. And here's where we attach a list of effects the entity gains when the stat goes to 0. It's this and the information from the value stat above it that ultimately tell the UI what to display and when to update. The UI side of things is worth its own separate video, so I won't go into that right now. Let's head back up to the top of the tree and have a look at status effects. Status effects are things which affect stats for an amount of time. That duration can range from an instant to forever. A healing pack would instantly increase your health, whereas an energy drink might increase your energy regen stat by 10 for 15 minutes so you can recover from sprinting faster. The player has a permanent hungry effect, which is constantly reducing their hunger stat. Eating doesn't change the fact that you're hungry, it changes how hungry you are, and increases your hunger stat. It does not get rid of a hunger effect. If an entity has stats, it has to have effects and vice versa. If an entity can receive effects, it must also have some stats to be affected. It might not have all or any of the stats, but it must have a stats component attached to it so the effects can find out. The effects component allows us to attach effects to any entity and holds the list of active effects. Whereas the stats component sat waiting for things to happen, the effects component triggers things to happen. At its heart, it's a timer with a list of effects to trigger. It waits tick rate seconds and then calls the collection of effects to do their thing, through their tick method. It also helpfully exposes the list of active effects to other components and entities to query. It uses the same collection wrapper pattern I've used around stats data. Let's have a look at the active effects data resource now. Most of the code here is just like the stats wrapper. The real work of this resource is done in its tick method. It's given a reference to the entity's stat component through which it applies all of its stats adjustments via the stat component stat collection. Tongue twister. It then checks to see if the effect needs to be expired and does so if necessary. That's why we traverse the array in a reverse order, so we don't mess up the indexes of the effects above us in the array. Let's dig into the active effect data. This is very much like the stat value data resource. It has a reference to an effect, and through that the list of stats it alters. It also tracks the severity of the effect, its initial duration and the current remaining time. Anything that will change emits a signal so that once again the user can keep up to date. Which leads us to the last piece in the puzzle, the status effect data resource. This, like the stat data resource, just holds information necessary to display it in the GUI and the additional stat adjustments associated with the status effect. And here's what the starving effect looks like in the inspector once it's fully populated. It has one stat effect, health, which it reduces by 1 for every tick. And that's the system for stats and status effects. I hope I didn't make a complete pig's ear of this description. I have no doubt that in the future both stats and effects will be expanded a little, perhaps to allow effects to generate other effects and not just affect stats. But whatever needs to be done, I feel pretty confident this is a robust basis to go forward with. And that wraps up this episode. Even I didn't think I was going to make it to 5, but here we are and I'm still not finding it a drag. On the contrary, writing my thoughts down and explaining them to others is a massive help when it comes to designing systems. If I can't explain it to another human, I have no hope of being able to explain it to a computer. As usual, I've no idea what will be in the next episode. Might be the GUI elements to go with this, but there's also items in inventory which slot nicely into this, so we'll see. Thanks so much for watching. If you do find anything useful or have any comments, give me a subscribe and pop a question down in the comments. If I can't explain the answer in the comments, I'll probably make it up as a video. So please, subscribe, like, comment and share if you think somebody else might find this useful. And I'll see you in the next one.